Okay. The Joule Thompson coefficient is positive at and below room temperature for all gases, except hydrogen and helium. So hydrogen and helium are the only two gases that have a negative Joule Thompson coefficient. This means that hydrogen and helium become hotter upon Joule Thompson expansion. All the other gases that pass through that pipe, upon a Joule Thompson expansion, the gas will cool. I mean, intuitively you know this just from your own experience with, the expansion of gases and what you did in general chemistry. When a gas expands, it tends to cool. A Joule Thompson expansion, which is keeping the enthalpy of the system constant, it's really, really strange that hydrogen and helium actually end up getting hotter when the volume expands. That's very, very odd. Every gas, including hydrogen and helium, every gas has a temperature above which the Joule Thompson coefficient becomes negative. The Joule Thompson inversion temperature. They call this the Joule Thompson inversion temperature. So at room temperature, carbon dioxide gas, if you do a Joule Thompson expansion, it's going to cool. But above a certain temperature, whatever it happens to be for carbon dioxide gas, I don't know, above that temperature, if you do a Joule Thompson expansion, it's going to actually get hotter. So that's called the Joule Thompson inversion temperature. Now for hydrogen gas, the inversion temperature is negative 80 degrees Celsius. So below this temperature, hydrogen actually cools. We said above which, well, in the particular case, under normal circumstances, hydrogen has a negative Joule Thompson coefficient. Below this temperature, so 80 is the inversion temperature, negative 80 degrees Celsius is the inversion temperature for hydrogen gas. So below this, it actually cools. So if I'm doing a Joule Thompson experiment for hydrogen gas, doing a Joule Thompson expansion, if I run it below about negative 80, negative 90 degrees Celsius, at that point, upon expansion, the hydrogen gas cools. So again, at or below room temperature, this is going to be most of what we do, all gases have a positive Joule Thompson coefficient, okay? That means if the pressure drops, the temperature drops. If the pressure rises, the temperature rises. It's positive. They correlate. They have the same sign. The delta T and the delta P, they have the same sign. Only hydrogen and helium are switched. Okay. Thank you for joining us here at Educator.com. We'll see you next time. Bye-bye.